So welcome for today's class of mathematics. In today's class, let us see the definition of a matrix. Also, in today's class, I am going to give you all types of matrices with definition. So 13 matrices I will be teaching you all. But before that, take the definition of a matrix. Take down the question. Answer. What is a matrix? A rectangular arrangement of mn numbers written in m rows and n columns and enclosed in bracket is called a matrix of order m by n. The order m by n is written as m into n. The number which form a matrix are called the elements of the matrix. Matrices are denoted by capital letters like A, B, C, D up to so on, etc. The elements of a matrix are denoted by small letter. Now the elements of the matrix is denoted by small letters, that is A, B, C, small a, small b, small c, up to small d and so on, means etc. For example, we have a matrix, this is matrix of order 2 by 3. So minus 1, 3, 4, 5, 2, 7. Now this is a matrix of order 2 into 1. So 4 and 6 is given. So this is the example. Now moving towards the types of matrices. What is a row matrix? A matrix having only one row is called a row matrix or a row vector. For example, this 5, okay, in the bracket you all can see, right? It is having only one row. Then we have one more bracket, minus 1, 4 we have, that is also one row. Now this is also considered it has a one row, that is minus 5, 6, 10. Okay, here there is a comma. Okay, you all can put comma over here. 6, 10 and row matrices or row vector. So these are row matrices or row vectors. These three you all can see. These are the examples. Now you all note a row matrix can have any number of columns. A row matrix has an order of the type 1 multiplied by n. So this is the type, okay, order of the type. So I can take down this. This will be useful for you all for 11th, 12th and also for your graduation level as well. So clear the concept of column matrix. A matrix having only one column is called a column matrix or column vector. So here you all are having an example of it, that is P, comma, this is one column. So columns are like this, okay, 3 and 12, minus 4, 8, 9. So it is in this form. These are the columns. In the previous class, I have already told you all how you all have a row matrix. Row matrix will have it like this. 1, 2, 3. This will be the row matrix. Okay. This is the row matrix. So we are here, but in this concept, in today's concept, we are only discussing about the column matrix. So these are the example of a column matrix or column vectors, you all can say. Note, a column matrix can have any number of rows. Therefore, a column matrix has an order of the type m into 1. Okay, m multiplied by 1. So I can take the square matrix. Okay, let us clear this topic. Okay, a matrix, you all can take down this definition or can say statement or definition. And take down this, a matrix of order m into n is called a square if m is equal to n. That is, the number of rows is the same as the number of columns. For example, we have this x. So here the matrix of m into n is called square matrix if m should be equal to n. The number of rows is the same as the number of columns. For example, we have 2 over here, 2 rows and 2 columns. So number of rows is equal to the number of columns. So You can see this is a horizontal, and horizontal is a minus 8, 13, minus 15 are horizontal, right? Which means they are rows. When we talk about the columns, minus 8, minus 12 and 10 are the columns. So 1, 2, 3, 1, 2, 3. So here rows and column are same, right? So this is M into N matrix. Okay, now these are square matrices. Now these are square matrices because they are equal number of rows and equal number of columns. Here also equal number of rows and columns. The order are 1 into 1. Okay, the first one is 1 into 1. The second one is 2 into 2. And the third matrix is order 3 into 3 respectively. I can take down this. Also, I can take down the continuation of that. A matrix of order n into n can be referred to as a square matrix of order n. Hence, by a square matrix of order 2, we mean a matrix of order 2 into 2. Similarly, by a square matrix of order 3, we mean a matrix of order 3 is to 3. In a square matrix, A is equal to Aij, the element, now this element Aij, when I is equal to j, if I is equal to j, it is called diagonal element of the matrix, and the element Aij, when I is not equal to j, if I is not equal to j, it is called to be non-diagonal element of the matrix. For example, for a square matrix A, where A is equal to x, A, B, P, Y, Q, R, S, Z. Now x, y and z are diagonal elements and all the remaining elements are non-diagonal elements. Okay, we have only one diagonal element, that is x, y, z. That is the only diagonal element and all the remaining elements are non-diagonal element. Okay, so remember this. So I hope you have understood the concept of the square matrix. First, write down the diagonal matrix. Diagonal matrix, a square matrix in which every non-diagonal element is equal to 0 is called a diagonal matrix. Or if A is equal to Aij is a square matrix with Aij is equal to 0, phi is not equal to j, then A is a diagonal matrix. Note that the definition of a diagonal matrix does not specify anything about diagonal elements. All it says is that the non-diagonal elements are zeros, hence its diagonal entries may or may not be zeros. A diagonal matrix is denoted by D. If D1, D2, D3 are the diagonal elements of a diagonal matrix of order 3, we write it as D is equal to diagonal, that is D1, D2, D3. Okay, so for example, you all can take down 1, then 4, 0, 0, minus 2. These are the examples. Okay, 3, 0, 0, 0, 0, 0. Here 0, 0, 7 is there. This is 3 into 3 matrix. This is 2 into 2 matrix. This is all zeros are there. So here 0 and 0. Okay, so what does it says that D1, D2, D3 are the diagonal element of a diagonal matrix of order 3. So this is of order 3. Okay, now here all it says that non-diagonal element are zeros, hence its diagonal entries may or may not be zeros. Not necessary, it may be 0, may not be. So it is 0, 0 over here. Here it is non-zero. Okay, so these are the examples of a diagonal matrix which I can take down. So write down scalar matrix, the definition of the scalar matrix or the statement of the scalar matrix. A square matrix having non-diagonal elements 0 each and whose diagonal elements are equal is called a scalar matrix. So it says that there is a square matrix having non-diagonal elements 0 each and whose diagonal elements are equal. So it is called as scalar matrix. Okay, remember these clearly. Or you can say that Aij, if A is equal to Aij is a square matrix such that this first one, there are two conditions which are given where aij is equal to 0 for I is not equal to j. B1 is aij is equal to k if I is equal to j, where k belongs to real. K is a constant over here. It belongs to a real. So then A is a scalar matrix. Once again note that there is no restriction on k. It can be 0. So this can be 0 also. Now you can take down the examples. For example, this is a 0 matrix. Now you have a matrix with 0 diagonal here, and this side it is non-zero. So 6 0 0 0 6 0, like this way. These are the example. 3 by 3 and here 3 by 3 matrix 0 0 0, all 0 are scalar matrices. Now you can take the note. These are the example of the scalar matrix. Now this is a note. A scalar matrix is always a diagonal matrix, but a diagonal matrix is not necessarily a scalar matrix. For example, you all have it to be 5 0 0 10 is not a scalar matrix, but it is a diagonal matrix. So this is a 0 matrix or null matrix. You can call this as 0 matrix or null matrix. Sixth one it is. So write the statement or definition. You can say a matrix having every element has 0 is called a 0 matrix or a null matrix. Okay, it is denoted by 0. 0 matrix means it will consist of 0 only. Okay, for examples, you all can see the examples of the 0 matrix or null matrix. It's one and the same. Like this is a matrix consisting of 0. This is 1:1 matrix. This is 2:2 matrix. Okay, all rows and columns are filled with 0. Here the column is filled with 0. Here the column and rows are filled with 0. Here this is 3:3, right? All are 0 only. Okay, so let me rub this part. You all can write down this. This is only for your knowledge purpose. Now these are 0 matrices of order 1:1. This is order 2:2. This is order 3:1. This is order 2:3, and the last one is with order 3:3 respectively. Note, the first one is a 0 matrix may or may not be a square matrix. The second one you all can take down is a 0 matrix which is a square matrix is always a diagonal matrix as well as a scalar matrix. So this is a unit matrix, or even you can call it as identity matrix. Okay, so let us discuss about the unit matrix or identity matrix. I will be giving you all the definition. Okay, let me zoom it little bit so that you all can see it better. Okay, unit matrix, identity matrix, a square matrix having every non-diagonal element equal to 0 and every diagonal element equal to 1 is called a unit matrix or an identity matrix. Or even you can write it as this. Or if A is equal to aij is a square matrix such that, now there are two conditions which are given. One is aij is equal to 0 for I is not equal to j. Second condition is aij is equal to 1 for I is equal to j. If I is equal to j means aij is equal to 1. This is only for this condition. You can take down. Then A is a unit matrix, has an identity matrix. In the bracket you can write down. A unit matrix is denoted by I. Okay, or even you can call it as identity matrix. For example, these are the examples which you can take down. 1 matrix 1. Okay, this is with order 1, this is with order 2, and this is with order 3. Okay, 1 0 0 1 1 0 0 0 1 0 0 0 1 are unit matrices of order 1 2 and 3 respectively. You can take down the note. A unit matrix is always a diagonal matrix as well as a scalar matrix. So it is a diagonal as well as scalar matrix. So you can write it down. You can take down this upper triangular matrix first, okay? So we are discussing about a triangular matrices. So the first one is upper triangular matrix, okay? A square matrix in which all the elements below the diagonal are zeros is called an upper triangular matrix. Or if A is equal to Aij is a square matrix where Aij is equal to 0 for I greater than j, then A is called an upper triangular matrix. So in this definition it is given when you can say that it is upper triangular matrix. So this is the condition. Aij is equal to 0 for I greater than j. For example, this is a matrix 2. Now this is a matrix 2 by 2. This is 4 minus 1, 0 and 8. Okay, a square matrix in which all the elements below the diagonals are 0. So below the diagonals the element is 0. Here it is 0. Over here this is this is a diagonal, and below diagonal the elements are 0. Okay, now these are called upper triangular matrices. Now let us see the lower triangular matrices. You can take down this. So let us discuss the lower triangular matrix. A square matrix in which all the elements above the diagonal are 0 is called a lower triangular matrix. Or if A is equal to Aij is a square matrix where Aij is equal to 0 for I less than j. Here I is less than j. Then A is called a lower triangular matrix. A square matrix in which the elements above, so above the diagonal are 0. Above the diagonal are 0 means, for example, this is a matrix 1. Here there is a diagonal, and above the diagonal the element is 0. Here above diagonal the element are 0 above. See. Here it is below the diagonals the elements are 0. Here above the elements, okay, the diagonals are 0. Elements above the diagonal are 0 over here. So these are called lower triangular matrices. Okay, this is a continuation. A matrix which is either an upper triangular matrix or lower triangular matrix is called a triangular matrix. Note, you all can take down this note. Diagonal matrix, scalar matrix, unit matrix and a zero matrix which is a square are always upper as well as lower triangular matrices. Okay, so I can take down this. I hope you have understood. So take down the statement of the determinant of a matrix. The determinants were discussed in details in the previous chapter. Now since a determinant is a square arrangement of a number, it is clear that one can find a determinant of a square matrix only. Now if a square matrix, then its determinant is denoted by determinant of A. So how we denote it as this, or DETA, det A, meaning determinant of A, comma, which is to be read as determinant of a matrix A. Thus if A is equal to, now this is a determinant A1, A2, B1, B2, then determinant of A is equal to determinant of A, you can write it in either way, is equal to A1, B1, A2, B2. Therefore, by definition, determinant of A is equal to determinant of A, DETA, is equal to A1. Now, these you all are multiplying A1 into B2 minus A2 into B1. This is the rule. On the same lines. Okay, the continuation is right over here. Suppose if this thing is given to you all, if A is equal to, now this is a matrix A1, B1, C1, A2, B2, C2, A3, B3, C3, then determinant of this matrix A is equal to determinant of A, which is equal to, you all have to write this determinant. Then A1, B1, C1, A2, B2, C2, A3, B3, C3. And by definition of determinants, determinant of A is equal to determinant of A is equal to, keep this A1 out, okay, over here. Now multiply this. So this thing you all are not taking, right? Cross multiply. So multiply this B2 C3 minus B3 C2. Okay. Next you all will be taking B1. So if you take a B1 over here, it will be, so you all are not using this and this. So multiply A2 into C3 minus A3 into C2. Then plus the last one, that is the C1. Okay, C1. So we are not using this row and this column. So we have to multiply these into this. Now this is A2 B3 minus A3 B2. Right over here. Okay, let me rub this. Now for example, if A is equal to 4, 6, 3, 5 is given to you all, then what will be the determinant of this matrix? It will be 4, 6, 3 and 5. So what I have done over here is, I have multiplied these 4 5s are 20 minus 3 6 are 18. Okay, so it is minus 18, which will give you nothing but 20 minus 18 is 2. So we are cross multiplying here. 4 5s are 20 minus 3 6 are 18, which is equal to 2. So I hope you have understood the concept of determinant of a matrix. So take down this singular matrix, write down singular matrix. What does it state? If A is a square matrix, okay, if A is a square matrix and determinant of that square matrix is equal to 0, then A is called, I hope you all can see this clearly, then A is called a singular matrix. Okay, if determinant of A is equal to 0, then only you can say that A is called a singular matrix. For example, if you all have a matrix that is 4, 6, 2 and 3 is a singular matrix, since now this determinant of this given matrix that is 4, 6, 2, 3, how we write it as? We just multiply this and this, right? 4 3s are, you wrote 12, that is you'll have to multiply 4 3s are, okay, then minus 6 2s are, okay. So 4 3s are 12 minus 6 into 2 you all are doing, so 6 2s are 12. So basically 12 minus 12 is going to give you all 0. Okay, so I hope you all have understood the concept of singular matrix. And take down this 11th one, a non-singular matrix. A square matrix which is not singular is called a non-singular matrix. Okay, this is the statement or the definition. I can write, say, thus if A is a square matrix, then determinant of this square matrix A is not equal to 0, then A is called a non-singular matrix. So with the help of an example, let us see if A is equal to minus 6, 2, 5 and minus 2. Now this is a matrix. Then what will be the determinant of this given matrix will be? Now if you put determinant for A is equal to this determinant of this given matrix is what? Minus 6, 2, 5 and 2. Well, when you multiply this, minus 2 multiplied by minus 6 is going to give you all positive, right? Minus and minus, it is plus, so it will be positive 12. And when you multiply this, 5 2s are 10. Okay, so we are just cross multiplying this. So 6 2s are 12 minus 5 2s are 10. So 12 minus 10 is going to give you all 2. So it is not equal to 0. So the determinant of A will be not equal to 0. Therefore A is a non-singular matrix. When it comes to the singular matrix, what happens? For singular matrix, the determinant of A will be equal to 0. But for this non-singular matrix, the determinant of A will be not equal to 0. This is the example of that the determinant of A is not equal to 0. Okay. So I hope you have understood the concept of a non-singular matrix. So write it down. Transpose of a matrix. Okay, transpose of a matrix. This is the statement or the definition, or can say A is a given matrix. The matrix obtained by interchanging the rows and columns of A is called the transpose of A and is denoted by A dash. For example, if you have A is equal to A1, A2, A3, B1, B2, B3, then A dash, which is a transpose. Okay, transpose is equal to, how we write it in, now this is in the row. Now you all are writing it into the column form. Okay, we are changing this is the interchanging of the rows by and columns. This is a row and this is the column. So we are interchanging the rows and columns. So it will be A1, A2, A3. Okay, this will become a column A1, A2, A3, and this again here B1, B2, B3. Now observe that continuation is right over here. In order A is equal to M multiplied by N, then order A transpose is equal to N multiplied by M. Note that if A is a square matrix, then order A is equal to order of A transpose. Take down this symmetric and skew symmetric matrices. Wait, let me. So this is a symmetric and a skew symmetric matrices. Okay. A square matrix A is said to be symmetric if A is equal to A transpose. The B1 is skew symmetric if A is equal to minus A transpose. For example, they are given matrix that is 2, 5, 5, 3, A, B, B, C are symmetric matrices. Now these are called as symmetric matrix. Okay, symmetric matrices. Okay. So A is equal to A dash. And for skew symmetric we have, now here all are positive, whereas here one is negative, minus A. Okay, now 0, minus 4, 4, 0 and 0, A, minus A, 0 are skew symmetric matrices. So this is the example of a symmetric matrices and this is the example of a skew symmetric matrices. Okay, so I hope you have understood the concept of a symmetric and skew symmetric matrices. And thanks for watching. Don't forget to like, subscribe my channel and share with your friends. Press the bell icon for more updates.